Greetings and welcome. This is Dr. B.D.Y. Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we are going to see the tutorial question bank discussion in Introduction to Engineering Mechanics. So this is the first module which we are going to discuss, the question bank which is provided for the Engineering Mechanics subject. In the question bank, some of the main problems or important problems which covers the basic formulae and basic principles of engineering mechanics are being discussed here. So coming to the first problem in the tutorial question bank, the problem given is identify the magnitude and the direction of the resultant of two forces 7 Newton and 8 Newton acting at a point with an included angle of 60 degrees in between them. So as per the discussion, we need to confine each and every word that is given in the problem and need to understand what the problem given is. So the problem given, as it is saying, there are two forces present in this problem. One is 7 Newton force and other is 8 Newton force. And these two forces are acting at a point, and the angle between these two forces are given as 60 degrees. Also, there is a clue given here that 7 Newton force is horizontal. So if we consider this problem and start to do, first we need to draw the figure for the given problem. For understanding that, as per the given problem, let us say the point is here, which is point A, and the forces of 7 Newton is horizontal and the other force 8 Newton is acting at the point itself, and the included angle given is 60 degrees. So this is the problem given, and we need to identify the direction and magnitude of the resultant of these two forces. So as per the given problem, this would be the figure. So here we can understand that among the two forces, one force is horizontal and other force is inclined. So when we see an inclined force, what we need to do? We need to resolve this inclined force into horizontal and vertical direction forces. So if we consider that 8 Newton force, which is acting in this direction, we need to resolve this inclined force into horizontal and vertical mutually perpendicular component forces. So the horizontal component force would be like this and vertical component force would be like this. And the angle to which this 8 Newton force is acting is 60 degrees to the horizontal. So these two components of 8 Newton can be written as 8 cos 60 degrees and 8 sin 60 degrees. As this component is adjacent to the angle given, we can implement the cos trigonometric ratio, and the other mutually perpendicular component we can give sin trigonometric ratio. So in this way, the 8 cos 60 degrees and 8 sin 60 degrees are the mutually perpendicular components of the given force 8 Newton. Now, combining all these, we can say that there are three forces acting. One is 7 Newton horizontal force, 8 cos 60 degrees horizontal component force, and 8 sin 60 degrees vertical component force of 8 Newton force. So these are the forces. Now we can say that there are two horizontal forces and one vertical force. Now we can directly implement the resultant formula. Let us say the resultant of these two forces is acting in this direction, which is R, and it is acting at an inclination of theta to the horizontal, and these are the components of the mutually perpendicular components of the resultant R. So the equation can be given as the resultant R is equal to under root sigma fx square, which is the horizontal component forces square plus vertical component forces square. So with this we can say it is, if we identify the summation of horizontal component forces sigma fx, we can write it as horizontal force 7 and another horizontal force which is 8 cos 60 degrees, which is acting in the right hand side direction. That means it is a positive force. So plus 8 cos 60 degrees. So these two are the horizontal forces. So when you solve this, you can get the value of sigma fx as 11 Newton. 11 Newton. Similarly, if we find sigma fy, so that is given as only one vertical force is available in this system. So that can be written as 8 sin 60 degrees. So if you solve this, you can obtain the value of 6.93 Newtons. Now, implementing the horizontal summation components and vertical component into the given equation, we can obtain R is equal to under root 11 square plus 6.93 square. So with this, if you solve, you will obtain the magnitude of the resultant as 13.1 Newtons. This is the magnitude of the resultant of these two forces. Now, if you need the inclination to which the resultant is acting, we do have the formula theta is equal to tan inverse the vertical component, summation of the vertical components by summation of the horizontal components. So if you substitute the values, tan inverse, we have 6.93 by 11. So the inclination would be given as 32.21 degrees. So in this way, we have obtained the magnitude and direction of the resultant of 7 Newton and 8 Newton forces acting in the system. So at the end, you can give the result as the magnitude of the resultant is 13.1 Newtons acting at an inclination of 32.21 degrees to the horizontal. So this would be the solution to the given problem. So we need to keep in mind that whatever forces that are given in the system, the forces that are acting horizontally and the forces that are acting vertically, we need to clearly understand how the forces are acting and should proceed to the problem and solve the problem. So this is about the given first problem. Now let us go to the next problem, that is given as two coplanar forces act towards a point with an angle of 45 degrees between them. Okay, here it is given that there are two forces, coplanar forces. That means the forces are acting in a single plane, and the angle between these two forces is 45 degrees. And if their resultant is 100 kilonewton and one of the forces is 20 kilonewton, identify the other force. So here the value of resultant of the two forces in the system is already given, which is given as 100 kilonewtons, and one of the forces is given as 20 kilonewtons. So the information which is given in the problem is regarding the magnitude of the resultant, the magnitude of one of the force, and the inclination between the two forces acting in the system. So let us first draw the figure to the given problem. Here it is mentioned that there are two coplanar forces acting towards a point. So let us consider this as the point A, and let us take two forces that are force F1 and force F2. Force F1 and F2, and this is the resultant R. Let us consider this as the resultant R. So the inclination that is given between the forces F1 and F2 is 45 degrees. And the magnitude of the resultant is given as 100 kilonewtons. And one of the force, the magnitude of one of the force is given as 20 kilonewtons. So in this way, the information is given regarding the forces that are acting in the system. Now we need to find the other force, that is F1, right? So here, as per the problem given, we can say that the force F1 is acting horizontally, and at a 45 degrees inclination, the other force F2, that is 20 kilonewtons, is acting. And the inclination of this resultant, let us consider it as theta. So now let us start the problem. Here, as per the given conditions, the resultant R, which is acting at an inclination of theta, let us consider the components of the resultant as horizontal component and vertical component, that is R cos theta and R sin theta. So here we can understand that the horizontal components, let us first write what are the horizontal components given in the system. One is R cos theta, one of the horizontal force, which will be equal to the horizontal forces of the system. So what are the horizontal forces of the system? F1, force F1 is the horizontal force, so that would be F1, and the horizontal component of force F2, and the horizontal component of force F2 would be, as we have seen here, F2 cos 45 degrees. F2 cos 45. So from this we can write that 100, the magnitude of the resultant 100 cos theta is equal to the value of F1 we don't know. The value of F2 is given as 20 kilonewtons and cos 45. So if you solve this, we can write it as 100 cos theta is equal to F1 plus, if you simplify this, you will get 14.14. Put it as equation 1. Now consider the vertical component of the resultant, that is R sin theta. So this vertical component of the resultant will be equal to the vertical forces acting in the system. So the vertical forces that are acting in the system is only one, that is F2 sine theta, or we can say F2 sine 45. So when you solve this, you can get the value as 20 sine 45, and if you simplify this, you will obtain the value as 14.14. Okay, so we can say 100 sine theta is equal to 14.14. Now from this, sine theta value can be taken as 14.14 by 100. So if you solve this, you can obtain the value as 0.1414. So this gives the value of theta as sine inverse 0.1414, which will be equal to 8.13. So this is the inclination. Now substituting this 8.13 in equation 1, let us substitute this theta value in equation 1. That will give as 100 cos 8.13 is equal to F1 plus 14.14. So if you simplify this, you will get the value of F1 as 84.85 kilonewtons. This is the magnitude of the other force F1. So at the end of this problem, you can write the solution as the magnitude of the other force is 84.85 kilonewtons, acting at an inclination of, so this inclination is not been taken, it is not needed because this F1 force is taken as horizontal force. So in this way, we can say we have identified the F1 force, that is the second force in the system. As we have seen in this problem, the way in which this problem is solved is related to the components of the forces that are taken for the given system of forces in the problem. So as per the given data, we have seen that one of the force is acting at an inclination of 45 degrees and the other force, we have taken it as horizontal force. Also, for the consideration of the figure. Now coming to the next problem. The problem given is a force P is applied at O. This is point O, to a string AOB. This is the string given AOB as shown in figure. If the tension in each part of the string is 50 newtons, that means whatever tension that is been acting in each part, this part and second part, is given as 50 newtons. Both the values of tension is same. Find the direction and magnitude of force P for equilibrium conditions. So the force P that is being acted at point O, the inclination is given as theta, and this force P we need to identify. For doing this, there is a clue given, that is, we need to consider the equilibrium conditions. And what is this equilibrium conditions? We know that sum of all the horizontal components is equal to 0 and sum of all the vertical components is equal to 0. This is the equilibrium conditions for any system. So whatever forces that are acting in the system, if we equate all the horizontal components and all the vertical components to 0, then the system is said to be in equilibrium state. Simply, we can say that the resultant of a system is 0. if the resultant of the system is 0, then the system is said to be in equilibrium, right? So now with the help of this equilibrium conditions equation, let us solve the problem. So first let us take the free body diagram of the given problem. We can say, as per the given problem, there is a point at which the force P is acting, and this is the string. So if we consider this point and where the force is acting, we can say that the tension is acting away from the point, and the value of tension is given as 50 newtons. So the tension values of in both the directions or both either side of the point is same. So as we are considering sigma fx, that is horizontal components and vertical components, and we understand that this is the inclination of P that is given to the vertical as theta, and the inclinations of T1 in both the directions, both sides, it is given such a manner, 45 degrees and 30 degrees. That means if we take T here and T here, now when this is 90 degrees, we can say this would be 45 degrees, and this total inclination would be 60 degrees. So that is the problem given. So now we can say the horizontal and vertical components of this given tension, that is T, can be given like this. Horizontal component is in this direction and vertical component is in this direction. And for second thing also, the horizontal component is given in this fashion and vertical component is given in this fashion. So the inclination would be 45 degrees here and this would be 30 degrees. So this is how the information given in the system. So the needed inclinations, that is 30 and 45, we can consider here. Now we can imply this, all the horizontal component forces is equal to 0. So which will give, this implies minus 50 cos 45. That means we are taking this tension value and the horizontal components of the tension, that is T cos 45, and the vertical component is also T sin 45. Keep it in mind that this T cos 45 acting in left hand side direction, that means in the negative direction. We all have already understood that the forces that are acting in positive x-axis direction will be positive forces and negative x-axis direction will be negative forces. Then positive y-axis forces will be positive forces and negative y-axis forces will be negative forces. That is the system we will be following. So we can say that this T cos 45 is acting in the left negative direction. So we can take it as minus 50 cos 45. Then minus P sin theta. Here for the P force, which is given like this, the horizontal component would be in this fashion and vertical component would be in this fashion. Okay, and the theta value is given here. So the adjacent to theta inclination component would be P cos theta and this component would be P sin theta. Always remember, the component which is adjacent to the inclination would be cos trigonometric ratio. So here minus p sin theta will be considered, as you can observe here that the p sin theta is acting in the negative direction. Now coming to this t application, here the component would be t cos 30, and also this t cos 30 is acting in the positive x-axis direction. So we can directly take that as plus t cos 30 degrees is equal to 0. So all the components is equal to 0. Here first we are going to take sigma fx is equal to 0 equilibrium equation. Hence the equation is given like this. Now when you solve for this equation, we can say p sin theta is equal to 50 cos 30, then minus 50 cos 45. So if you solve this, you will get p sin theta is equal to 7.95. So keep it this as equation 1. Now implementing sigma fy is equal to 0. So all the vertical components in this system is equal to 0. As we have seen, there are 3 forces and all the 3 forces are inclined forces. This is 45 and this is 30. Now the components, vertical component forces can be taken in this fashion. Here if you consider the vertical force of this t, it is acting in the positive y-axis direction. So that would be t sin 45. Also, if you consider this p, it is acting in the negative y-axis direction. So we can take minus p cos theta. Then this second tension t, that component, vertical component is also in the positive direction, y-axis direction. Hence plus t sin 30 is equal to 0. So these are the 3 vertical components in the system. So now if you simplify this, you can write it as p cos theta is equal to 50 sin 45 plus 50 sin 30. So from this you can write p cos theta is equal to 60.355. So this would be your equation 2. Now what we are doing? We are dividing this equation 1 by 2. So that means if we implement equation 1 by 2 here, we can write it as p sin theta by p cos theta is equal to 7.95 by 60.35. So if you simplify this further, you can observe that this p will get cancelled and sin theta by cos theta would be tan theta. And this tan theta value is obtained as 7.95 by 60.355. So further, theta can be obtained as 7.52 degrees. So this is the theta value of the given system. Now, for obtaining the magnitude of force P, we can substitute this theta value in any of the equations 1 and 2. any of the equations 1 or 2, we can substitute the value of theta. So substituting the value of theta in equation 1, that means P sine 7.52 is equal to 7.95. This will give the, if you do the further simplification, this will give the value of P as 60.74 newtons. So this is the magnitude of the force P. So in this way, we can solve the problem. So after solving the problem, the end result can be written as the magnitude of the unknown force P is 60.74 newtons and acting at an inclination given as 7.52 degrees to the vertical. So this is how this problem is solved. Now coming to the next problem, determine the resultant of system of forces acting as shown in figure. So here in this system that is given, there are 5 forces acting. You can observe here, this is force 1, 400 newtons, force 2, 80 newtons, force 3, 300 newtons, force 4, 500 newtons, force 5, 200 newtons. And for all the forces that are acting in the system, the inclinations are given such that this 400 Newton force is acting at an inclination of 30 degrees to the horizontal. This 80 Newton force is acting vertically. Directly, the direction of this 80 Newton force is vertical. Then this 300 Newton force is acting at an inclination given in the form of right angle triangle. So we can simplify this to obtain the inclination using our trigonometric ratios. Here the inclination or the sides of the right angle triangle are given as 3 and 4. So obviously we can apply, for obtaining this inclination, we can directly apply the trigonometric ratio tan theta. Okay, tan theta is equal to opposite by adjacent. So if you simplify this, the value of theta, or else we can take this as theta 1. The value of theta 1 as 36.87 degrees. So whatever inclination that this 300 Newton force is acting can be taken as the inclination as 36.81 degrees. Okay. Now coming to this 500 Newton force, again this inclination is given in the form of right angle triangle. So for this right angle triangle that is given, for obtaining this inclination, nothing but this inclination, let us take it as theta 2. The sides given are 1 and 2. So here also if we obtain or if we apply tan theta 2, taking it as opposite by adjacent, which will yield in the result of theta 2 as 63.43 degrees. So this inclination of 500 newtons to the horizontal can be taken as 63.43 degrees. Now the other thing, the final force, that is 200 Newton force, it is given that it is acting at an inclination of 50 degrees to the vertical. But all the inclinations we are going to take or consider to the horizontal, hence this inclination would be 40 degrees. This is how the free body diagram of the given system is taken. So with these inputs, we can obtain the resultant for the given system of forces. We can obtain the resultant of the given system of forces. So first let us take the horizontal component forces, that is sigma Fx. The values of all the horizontal component forces, let us consider first. So we can take the horizontal component of this 400 newtons as 400 cos 30. So if we see that individually, let us say the force is taken individually outside and the force of 400 Newton is acting at an inclination of 30 degrees. So the components of this force, 400 Newton force, can be given as horizontal component 400 cos 30 and vertical component 400 sin 30. These are the mutually perpendicular components of this 400 Newtons force. You can observe here that this 400 cos 30 component is acting in the positive x-axis direction. So we can directly take it as positive value. So this would be one force, that is 400 cos 30, which is acting in the positive direction. Then coming to the second force, that is 80 Newton force, it is directly acting in vertical direction. So there is no horizontal component for this force. So we can eliminate this. Then coming to this 300 Newton force, the horizontal component of this 300 Newton force would be acting in the negative direction and the component value would be 300 cos 36.81 degrees. That would be your horizontal component force. So as this is acting in the negative direction, that is negative x-axis direction, we will take it as a negative force. So the value would be minus 300 cos 36.81 degrees. Now coming to the next force, that is the 500 Newton force. The horizontal component of this 500 Newton force will be acting in the left hand side direction. How we are obtaining these directions of the component forces? Let us take this example of 500 Newtons. As the 500 Newton force is acting in this direction, how we will obtain the component forces? We need to start from the starting point of the force and we need to reach the end point of the force, that is the arrowhead of the force. So if we start from this point and go towards left side till this arrowhead, then that would be one component and we need to reach that arrowhead in this fashion. So this would be your horizontal component and this would be your vertical component. So as this vertical component, vertical direction, we can shift this vertical direction component to the point here, showing it as like this. So this would be your vertical component given here at the point, that is 500 sin theta. Why we have kept sin theta here? Because it is other than inclination side component. Then for this component, we can write it as 500 cos theta, which is the adjacent to the inclination side, adjacent to the inclination. So in this way, 500 cos theta and 500 sin theta are the mutually perpendicular component forces of the given force 500 newtons. This will be taken care only when the given force is acting in the inclined direction. The given force is acting in the inclined direction. That you need to keep it in mind. Now, the third force, which is 500 newtons, we can write the component as minus 500 cos 63.43 degrees. Why we have taken this minus direction again, minus symbol? The negative symbol is taken because the component is acting in the negative direction, negative axis direction. That's the reason we have taken it in the minus form. Now coming to the final thing, that is 200 Newton force. This 200 Newton force, the horizontal component would be acting in the right hand side direction, that is positive axis direction. So that positive axis direction we can take it as 200 and the inclination is 40. So that is cos 40. So that would be a positive force. So plus 200 cos 40. Always keep in mind, as we have discussed earlier, all the positive axis direction forces will be positive forces and all the negative axis direction forces will be negative forces. So keep it in mind, and while considering the direction, you can use any form, but from the starting of the problem until end of the problem, you should use the same unidirectional method. That is, if you consider left hand side axis forces, that is negative axis forces, as positive forces, you can do that. There is no problem in that, but you need to continue to use the same signs conventions till the end of the problem. So keep it in mind. Now, for the given in the 5 forces, one of the force is only vertical. So remaining 4 forces, horizontal components we have taken, and the sign conventions are being taken care. So when you solve this, you can get the value of sigma fx is equal to 35.97 newtons. This is all the summation of all the horizontal component forces. Now considering the summation of all the vertical component forces. For the vertical component forces, we can observe here that 4 are the inclined forces in the given system and 1 is the vertical force. So totally we will be obtaining 5 vertical component forces. So 5 vertical forces will be obtained from the given system. So starting from this 400 Newton force, we can consider from this point, the vertical component of that 400 Newton force would be 400 sine 30. And this 400 sine 30 is acting in the positive y-axis direction. So we can consider it as positive force. So we can write it as 400 sine 30. Now coming to the second force, that is 80 Newton force. This 80 Newton force is completely vertical. So we can take it as positive, and also it is acting in the positive axis direction. So we can take it as plus 80 newtons. Then coming to this third one, the vertical component here would be in this direction. That means a positive direction. So that positive direction, the vertical component would be in this direction. Hence we can consider it as 300 sine 36.81 degrees. Okay, this would be your positive component, that is vertical component of the force, and also it is acting in the positive y-axis direction. So we can take it as a positive force. So that would be plus 300 sine 36.81 degrees. Okay. Now coming to the next force, that is 500 Newton force. The vertical component of this 500 Newton force would be acting vertically downwards in this direction. Okay. And the value of this thing would be sine 500 sine 63.43 degrees. So this sine 500 sine 63.43 degrees, this component, it is acting vertically downwards. That means negative y-axis direction. Hence we can take it as a negative force. So putting that in the equation, minus 500 sine 63.43 degrees. Then again, the final force, that is 200 Newton force. So we can take that the vertical component as coming downwards, and the force would be 200 sine 40. So the value of sigma fx that is obtained is 35.97 newtons, and the equation of sigma fy is written as 400 sine 30 plus 80 plus 300 sine 36.87 minus 500 sine 63.43, and the final component minus 200 sine 40. This minus 200 sine 40 is because it is acting in the downward direction, and that value would be 200 sine 40 degrees. So when you simplify this, you will obtain the value as minus 115.75 Newton. So now we have got summation of all the horizontal components and summation of all the vertical components. Now we can apply these values in the resultant equation, as R is equal to under root sigma fx square plus sigma fy square. So when you solve this, you can get the value as 35.97 square plus minus 115.75 square. So when you simplify this, the magnitude will be obtained as 121.21 Newton. This is the magnitude of the resultant. Now coming to the inclination. So inclination part, we can take it as theta is equal to tan inverse sigma fy by sigma fx. The equation we have. So that can be simplified as tan inverse minus 115.75 by 35.97. So when you simplify this, you will obtain the value as minus 72.74 degrees. So this is the inclination of the resultant that is acting. The negative symbol here, you can obtain the value as the total 360 degrees minus 72.74, that can be given as 287.26 degrees from the 0th position. From the 0th position we can take. Or else we can show this minus 72.74 degrees, that is the resultant will be acting in this direction. This is the resultant. Here you can observe here that this horizontal component of the resultant is positive. That means from the central point, the value is in the positive direction, and this is negative. The vertical component is negative. So from that point again, the vertical component is acting in the downward direction. So obviously we can say that the resultant is acting in the 4th quadrant. So the inclination we can consider it as 72.74 from the horizontal. Or else we can take it from 0th position, and the inclination can be given in this fashion. The inclination as 287.26 degrees. Right? So at the end, you can write the solution as the resultant of the given system of forces is 121.21 newtons acting at an inclination of 72.74 degrees down the horizontal, or else 287.26 degrees from the 0th position. In this way, you can give the solution. Now let us go to the next problem. So in this next problem, you can see that the information that is given is with respect to the directions of east, west and north, south. So there is no figure that is given to this problem. So what we can do, we can first draw the figure according to the given information. So let us start the problem. The problem given is the following forces act at a point that is given in the form of east, west and north, south. So what we do, first let us draw a box that will implement our directions. Let us take this as the box and this as the axis of the box. Let us consider this as the east direction. This would be our west direction. This would be our north direction and this would be our south direction. Now, this is the origin or the point at which the forces are acting. Let us start the problem now. The first point or first bit that is given is 30 kilonewton force inclined at 35 degrees towards north to east. Okay, towards north to east. That means the inclination that is given it is acting in this direction at 30 degrees and the inclination given is 35 degrees here, north to east. Then the second point that is given is 22 kilonewtons acting towards north. So the force is acting towards north in this direction. That is 22 kilonewtons or 22 kilonewtons. Then the third one that is given is 30 kilonewtons inclined at 30 degrees towards north to west. Towards north to west. So that means this is the force that is acting, that is 30 kilonewtons and the inclination is given is 30 degrees. Now the fourth one is 35 kilonewtons, that is inclined at 25 degrees towards south to west. That means the force of 35 kilonewtons that is given towards an inclination of south to west at 25 degrees. Now find the magnitude and direction of the resultant force. So now you can observe here, this is very similar to the previous problem, wherein the direction of the forces is given in the form of the north, south, east and west directions. So this would be your figure, which is very similar to the previous problem. So here also what you can do, you can implement sigma fx. That means all the horizontal components of the forces, and keep it in mind that the direction in which the forces are acting should be taken as the directions from starting to end at the same convention, sign conventions. Then again you can find sigma fy is equal to, then you can put these values in R, the resultant equation, that is sigma fx equal to sigma fx square plus sigma fy square. Then the inclination can be obtained as theta is equal to tan inverse sigma fy by sigma fx. So these are the formulae which can be used for obtaining the solution. Now let us go to the next problem, that is a heavy cylinder of mass 280 kg is to be pulled over a curb of height 5 centimeters by a horizontal force F applied by means of a rope wound around the cylinder as shown in figure. So the mass of the cylinder that is kept here is given, which is 280 kgs. Then this cylinder is wound using a rope, and to that rope, at the end of this rope, there is a force of F is acting, and there is a curb. There is a curb of height 5 centimeters as shown here, and the force is being applied for rolling over this cylinder onto the curve. Now they are asking, determine the magnitude of pull, that means the force F, for the impending motion over the curve. That means the minimum force that is required for the movement of the cylinder to start. The motion should be impend. That means the motion should not happen, but the movement should not happen, but the movement should start. The minimum force that is needed for the movement should start. Here, the problem is in the static condition of the engineering mechanics. So, never in static conditions there will be a movement that is involved in the system. The only thing that is being asked is the minimum force required for the movement to start, intend to start. Not completely the movement of the object, just the movement should tend to start. At that condition, when the movement will tend to start, the contact point here, the contact of that cylinder to this floor will be losing. The contact will be losing. So, there won't be any reaction at this contact point because the contact will be lost. Once the cylinder tends to move, that starts to move, the contact will be released. Hence, there won't be any reaction at this point. That is the simple clue that we need to understand from this point. So, determine the magnitude of pull for impending motion over the curve, while the radius of the cylinder is 13 centimeters. So, the radius is given as 13 centimeters. So, from this, the given data, first let us get all the data to our SI units, because the mass is given here and the units are given in centimeters. Let us convert all these things to the SI units. So, first thing would be weight of the cylinder, that would be mass into acceleration due to gravity, that can be written as 280 kgs, that is given as mass, and 9.81 meter per second square as the acceleration due to gravity. Hence, the value would be 2746.8 newtons. So, the weight of this cylinder can be given as 2746.8 newtons. Then, the height of the curve, that is given as 5 centimeters. So, let us take it as height, that is 5 centimeters. Hence, it can be taken as 0.05 meters. Also, the radius of the cylinder, that is given as 13 centimeters, which can be taken as 0.13 meters. So, this is the given data, and we have converted all the data to the SI units. Now, let us draw the free body diagram of this given figure. Once we start to draw the free body diagram, this is the cylinder, and the distance from the center, the radius is given. This is the contact point where the reaction will be taking place, that is RA. Let us take this point as A, and the reaction would be RA. Then the weight that is been acting here, that is 2746.8 newtons. Then a force from this point, that is F, that is been acting here. Also, if we consider this as 0.13 meters, the radius as 0.13 meters, and the height, the horizontal height, this would also be 0.13 meters. The horizontal height is given as 0.05 meters. So, this distance that can be obtained will be 0.13 minus 0.05. So, the value can be obtained as 0.08. Okay. So, this value would be 0.08. 0.08. this length would be 0.08. So that is how, if we consider this as the right angle triangle, and this length would be obtained as 0.1. This length would be obtained as 0.1. Simple triangle equation. Now let us take the moment. Let us take the moment of this total system with respect to point A here. With respect to point A, let us take the sum of the moments is equal to 0. That is the equilibrium condition where the moment, sum of all the moments will also be is equal to 0. So let us take that moment. If we take the moment for the given system, the forces, number of forces acting here are force F as one force and the weight as another force. So these two forces can be considered, and we can see that the force F, the moment equation is force into perpendicular direction. So the distance, the perpendicular distance. So this point, from point A, the perpendicular distance would be 0.13. That is this distance 0.13 plus 0.08. Isn't it? 0.08. This would be your moment of this force F with respect to moment center A. And also this is the clockwise direction rotation. Hence we can take it as a positive moment. Now coming to the second force, that is weight, which is 2746.8 newtons. Here when we are considering point A, this force, that is weight force, is acting in the anti-clockwise direction with respect to point A. Hence this would be a negative force. So we can take that as minus 2746.8 into this distance, the perpendicular distance of this force towards the point A is 0.1. Okay, the perpendicular distance would be 0.1. So into 0.1. So when you solve this, you will be getting is equal to 0. When you solve this, you will be getting F is equal to 2746.68 by 0.21, that is equal to 1308 Newton. So the force which is needed for the cylinder to impede the motion is 1308 Newtons. So this is not completely taking the object to movement, but the movement will be implemented or induced in the system. So these are some of the important questions in the tutorial question bank which we have discussed. This completes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.